All right, what's up, you guys? So we're talking about neurons in this video. We have two neurons here, this first one, this second one. This first neuron is able to send a signal in this direction that will somehow get to this second one here. And we're just going to go through all the basics of neurons, so all the different parts, so we can say the words and know what they mean. All right, so where does a neuron receive input from other cells? From these guys here, the tips. These are called dendrites. Right, so the dendrites are at the tips. That's where they get information from. So an example that's kind of an exaggeration is let's say your hands is sending a signal to this one. It's like saying like, ow. Let's say your arm is sending a signal here. It's saying, ow. But let's say your leg is sending a signal here and it's saying, we're okay, right? So maybe your arm and your hand are on fire, but your leg is okay, right? Kind of an oversimplification, but that's how you can get signals from different areas, is because one neuron has lots of different dendrites, lots of different places to get information from. So one neuron, many dendrites. Right, so then this neuron will be able to conduct an electrical impulse. I'm kind of skipping to C right now. And that is the action potential. So that's the buzzword for us. In later videos, we're going to describe exactly how an action potential works. For now, it's just the electrical signal that travels from the body of the neuron. So like the biggest part, right, the fattest part of the body, the action potential will travel down this area, and this area is called the axon. Right, so this area is called the axon, kind of the long stringy part. And an action potential will travel all the way down the axon. So an important thing that we'll learn about neurons is action potentials only move down the axon. They never move back upwards. This is impossible, right? Keeps everything really linear, flowing in the right direction. Cool. So where on the neuron is the impulse first generated? So this impulse is talking about the action potential. Right, so the action potential happens down here. It's first generated in this area, like right before the axon. Or sorry, yeah, right before the axon, yeah. And this area is called the axon hillock. Right, so you have a ton of different dendrites sending a bunch of different information. So right here at the axon hillock is kind of where it processes that information. It says, should we fire an action potential? Should we not fire an action potential? The axon hillock is kind of summarizing all the information from the different dendrites. And that's where the action potential begins before it travels down the axon. All right, cool. Where does the neuron send signals to other cells? So, right, we have this axon hillock deciding when to send an action potential, the action potential flowing down the axon, and then the signal gets released. We'll talk about what the signal is in a second, by the tips of the axon. So these are the axon terminals. Right, it's honestly a pretty good name. It's axon terminals, so the end of the axon. Cool. So then this cell has to somehow send a signal to this cell, but they're not connected, right? We have this area here, this kind of area in between the two neurons. This area is called the synapse. So it's the space between two neurons. So this is synapse. Cool. And so we just talked about the axon terminal will send signals to the other cell. Now we're going to get a little bit more specific about what that signal is. It's a chemical signal. So the axon terminal will release neurotransmitters that will join into the next cell. So these are neurotransmitters. So I think these have a really good name, right? They're from a neuron and they're transmitting information from one neuron to another. So it's a chemical. We'll learn about these more. There are specific ones with different names that we'll learn later. Just know that it's after an action potential, it's the chemical signal. Cool. Then we have in every synapse, there's always a cell before and a cell after the synapse. we call the one before the synapse presynaptic, and the one after the synapse postsynaptic. So nice names, they say exactly what they are. Okay, cool. And then you notice these ones have kind of like, you see these little bumps. In between the bumps, these are the nodes of Ranvier. Great. So these little bumps, these are glial cells. We'll talk about those in more detail in a different video. Think about them basically as insulation for your neuron, electrical insulation. We'll explain this in a different video. You can always email me right now if you have questions. But note the nodes of Ranvier are in there. They're glial cells. And what do we find at the nodes of Ranvier? This is where we find all of the ion channels that cause the action potential. Right, so these are ion channels. So when they open, ions will flow in, flow out. That causes the action potential. So this all kind of make more sense and come together once we finish the action potential part. Just really quick though, I want to just summarize the information that we just talked about here. So goodbye to these notes. Just kind of putting it all together. So this first neuron, the presynaptic neuron, right? Presynaptic. Then we have the synapse. And here we have the postsynaptic. Right, so it's going to get some signal in its dendrites, getting a lot of signals in the dendrites. Then right here at the axon hillock, it's going to decide whether to fire an action potential or not. Let's say it does decide to fire an action potential. That action potential is an electrical signal that will travel down the axon. Once it reaches the axon terminals, they're like, okay, I got the electrical signal. Now it's time for me to release neurotransmitters. It's going to write NT for short. These neurotransmitters are a chemical signal that the next neuron can pick up with its dendrites. And then this neuron is receiving information in the dendrites from the other neuron before it. Then this neuron's axon hillock will decide to fire an action potential. Maybe it does fire an action potential, and then it releases neurotransmitters of its own. Right, so you can see how a really important thing is everything moves in one direction, like we're always moving down in this direction. Hopefully see how these are connected. So we have an electrical signal, the action potential, and the chemical signal, the neurotransmitters. And we'll talk about the action potential in more detail later, and we'll talk about the neurotransmitters in more detail later. For now, let me know if you have questions.